buried e-learning. Today we're going to have math class for Jss3 with the topic on the board areas of plane shapes. Areas of plane shapes. Before we continue, we look at what an area is. An area of any plane shape is the amount of space the shape occupies. An area of any shape at all is the amount of space that shape occupies. Now, plane shapes are actually shapes that are placed on a flat surface. Example, we have square, we have rectangles, we have circles, we have trapeziums. They are all examples of plane shapes. Any shape that can be placed on a flat surface is a plane shape. So we are looking at the different plane shapes and the formula for calculating their areas. For instance, we have a square, and we know that a square has 4 equal sides, and its area is given as length square or side square. The formula for calculating the area of a square. For a rectangle having length and breadth, the area is given as length times breadth. For a circle, now we have a circle. Any straight line that divides a circle into 2 equal parts is called the diameter. Any straight line that divides a circle into 2 equal parts is called the diameter. Now, any straight line that starts from the center of the circle to any part of the circumference is called radius. Any straight line that starts from the center of the circle to any part of the circumference is called radius, while the straight line that divides it into 2 equal parts is called diameter. It therefore means that 2 radii gives us a diameter. The plural form of radius is radii. So 2 radius gives us a diameter. The formula for calculating area of a circle is given as pi r squared. Pi r squared, where our r is radius and our pi is given as 22/7 or 3.142 as the case may be. I already told us that 2 radii makes 1 diameter, so a radius is diameter over 2. Half a diameter gives us a radius. We have the diameter on the board. From this point to this point is a radius. From this point to this point is another radius. We add the 2 to get 2 radii, which is equal to our diameter. We have another plane shape called the parallelogram. The parallelogram. Now, just like the rectangle, it has 4 sides. Opposite sides are equal and parallel, and it has the formula base times height. Base times height. But in some cases where the height is not given, you can also use the formula AB sine theta. In a case where the base is given and the height is not given, an angle will be given. So we either use this depending on the information given. If we have the base and the height, we use this. In cases where the height is not given, our angle will be given. So we use AB sine theta. We also have another plane shape referred to as the trapezium. We have a trapezium on the board. Now, for a trapezium, it has 2 opposite and parallel sides. These 2 sides are parallel to each other and they are always unequal to each other. We call this A and we call this B. Now, a trapezium is formed when a rectangle merges with a right angle triangle. A trapezium is formed when a rectangle merges with a right angle triangle. So, this is our height. The area for our trapezium is given as half into bracket A plus B times our height. Half into bracket A plus B times our height. Remember, our A and B are 2 parallel and unequal sides. We have this as our square. We have this as our rectangle. This is our circle. This is parallelogram. The sides are parallel to each other. Then we have our trapezium. Yes, we have one more. Where did I go? the triangle. This is a right angle triangle. This is our base of the triangle, this is our height. So the area is giving us half times base times height. The area of this triangle is giving us half times base times our height. There's another formula for calculating the area of a triangle which we look at when we are solving problems. We have half times base times height as the formula for calculating the area of our triangle. So let's solve the problem. Calculate the areas of each of the following shapes. We have a rectangle of length 7.1 cm and breadth of 4 cm. We have a square. Of course, we know our square has 4 equal sides of side 0.5 meters. We have a circle of diameter 10.5 cm. Then we have a trapezium. This trapezium is drawn this way, of sides 6 cm and 9 cm with our height of 6 cm. We have to find their areas. Now how do we do that? The first one is a rectangle having length of 7.1 cm and breadth of 4 cm. So we say area of rectangle. The formula is giving us length times breadth from our formulas here. We have area of rectangle with length times breadth. And our length is 7.1 cm while our breadth is 4 cm. So we have 7.1 cm times 4 cm. We multiply it till we get 28.4 cm squared. Cm squared because we are calculating the area. So since we say area of the rectangle is given as length times breadth, we multiply our length by our breadth. Our length is 7.1 cm multiplied by 4 cm to get 28.4 cm squared. So our area of rectangle is 28.4 cm squared. For our square, we know that the sides of a square are all equal. It has 4 equal sides. So we have that the length is given as 0.5 meters. Our area of a square, we have length square, and you can also give a side square. We have length square, which is 0.5 meters all square. To give us 0.5 meters times 0.5 meters. If you multiply it, we have 0.25 meters square. Let's calculate the area of a square with side 0.5 meters. And we say that the area of a square is given as length square or side square. So we are given a length of 0.5 meters. So we square it. 0.5 meters all square means we multiply it by itself. 0.5 meters times 0.5 meters. And that gives us 0.5 meters square. The next we have a circle. We have a circle. And I said this, any straight line that divides a circle into 2 equal parts is called the diameter. The area of a circle is given as pi r squared. Now, this straight line that divides the circle is the diameter. We have a diameter of 10.5 cm. I told us that our radius gives us the diameter over 2. 2 radii gives us our diameter, and our radius is diameter over 2. I said the radius is the straight line from the center of the circle to a part of the circumference. Since from here to here is 10.5, from here to here half of it gives us 10.5 all over 2. So our radius is 10.5 cm all over 2. So we apply our formula for calculating the area of the circle, pi r squared. We're told that our pi is 22 over 7. So we say 22 over 7 times our r, 10.5 cm over 2. We're interested in radius, they are no longer diameter. Then times 10.5 cm all over 2. We now divide through. 2 into itself is 1. 2 into 22 we have 11. 7 into itself is 1. Into 10 we have 1. We have our point remainder 3. Into 3 we have 5. So we have left 11 times 10.5 cm times 5 cm. And we divide by 2. We divide by 2. If we multiply through, we will get 36.625 cm squared. 36.625 cm squared. Let's take it again. Let's calculate the area of this circle of diameter 10.5 cm. Now, the formula for calculating the area of a circle is given as pi r squared. Our pi is given as 22 over 7, and we say that 2 radii makes a diameter. The diameter of a circle is a straight line that divides the circle into 2 equal parts, while a radius is a straight line that starts from the center of the circle to a part of the circumference. So 2 radii gives us 1 diameter. So in this question we are given the diameter. For us to get our radius, we divide the diameter by 2. We divide the diameter by 2. So we apply our formula pi r squared. Pi is 22 over 7 times 10.5 over 2 times 10.5 over 2. R squared means r times r. At this point we cancel out. 2 into itself is 1. Into 22 is 11. 7 into itself is 1. Into 10 is 1. Since we have a point, we add the point. Remember 3. Into 35 we have 5. So what is left? 11 times 10.5 times 1.5 all over 2. You have it here. 11 times 10.5 times 1.5 all over 2. We multiply that out and divide by 2. We have 86.625 centimeters squared. So the area of our circle of diameter 10.5 cm gives us 86.625 centimeter squared. The next one we have is a trapezium. A trapezium. Now, the formula for calculating area of trapezium is given as half into bracket A plus B times height. Half into bracket A plus B times height. Now we have our trapezium, and I say that our A and B are this and this respectively. These two parallel and unequal sides are called A and B, and our height is 6 cm. So we have half into bracket 6 cm plus 9 cm, then times our height of 6 cm. This will give us half times, we add 6 plus 9 gives us 15 cm times our height of 6 cm. Is 1, 2 into 6 is 3. So we are left with 15 cm times 3 cm. Now 15 cm times 3 cm, and that gives us 45 cm squared. So our area of trapezium is 45 cm squared. 45 centimeter squared. To solve another problem, find the area of the shape below. To 2 decimal places. We have the shape on the board. Now, this shape or this figure consists of 2 shapes. We have this a rectangle and this is half of a circle. We call it a semicircle. We have a rectangle and then a semicircle. So we will find the area of each of them. Let's begin with the rectangle. So we say area of rectangle. Since the rectangle is our length and this is our breadth. We have our length and our breadth. So we say area of rectangle is length times breadth, which is 11 cm times 3 cm. Length times breadth. 11 cm times 3 cm. That gives us 33 centimeters square. Then we now find the area of this semicircle. Area of semicircle. We are told that area of a circle is given as pi r square. Area of a circle is given as pi r square. A semicircle is half of a circle, so we say half pi r square. The area of a circle is pi r square. Since we have a semicircle which is half of a circle, the formula becomes half pi r square. Now, what we have is a square that divides this circle into 2, which is a diameter. Our radius will not be half of our diameter. So we have half times our pi is 22 over 7, 22 over 7 times our radius. This is diameter, so radius is diameter over 2 times our diameter over 2. Now, 2 into itself is 1, into 4 we have 2. 2 into itself is 1, into 4 we have 2. 2 into itself is 1, 2 into itself is 1. So we have left 22 times 2 all over 7. 22 times 2 all over 7. 22 times 2 gives us 44 all over 7. If we divide 2, we'll have about 6.29 centimeter square. 6.29 centimeter square. Remember, our answer is supposed to be in 2 decimal places. Now, we've succeeded in finding the area of our rectangle and area of our semicircle. We now add our 2 areas together to get the area of the figure we have on the board. Add our area of rectangle to our area of semicircle to get the area of the figure on the board. So, we say 33 cm square plus 6.29 cm square. Area of the shape. We have 33 cm square plus 6.29 cm square. If we add together, we get 39.29 cm square. That's our area of the shape. Let's go through it once again. Find the area of the shape we have on the board. Correct the 2 decimal places. And we have these 2 figures on the board. Now we are not told that we have 2 plane shapes on the board. It is left for you to figure out the figure you have, to know the number of plane shapes you have. Now looking at it, we see that there's a rectangle here having length and breadth. You can see these 2 opposite sides are equal. 7 plus 4 still gives us 11. And we have a semicircle on the board. So we apply formula for calculating the area of each of the shapes, beginning with the rectangle or any of them. You can start from here. So we started with the rectangle and our area is given as length times breadth. That's 11 cm times 3 cm and it gives us 33 cm square. And we can see that for our semicircle, from this point to this point gives us the diameter and it's given as 4 cm. The formula for calculating the area of a circle is pi r squared. But we have a semicircle, which is half of a circle. So the formula becomes half pi r squared. Now we have half times pi, 22/7, times 4/2, because our diameter is 4, our radius is 4/2, times 4/2. R squared means r times r. At this point we divide. 2 into itself is 1, into 4 we have 2. 2 into itself is 1, into 4 we have 2. 2 into itself is 1. So let's begin. 2 into itself is 1, into 4 we have 2. 2 into itself is 1, into 4 we have 2. So we now have 22 times 2 all over 7. 22 times 2 all over 7. 22 times 2 gives us 44. I will divide 44 by 7. We have 6.29 centimeters squared. So our area of semicircle is given as 6.29 centimeters squared. So area of the shelf becomes the sum of our area of rectangle and our area of semicircle. 33 cm squared plus 6.29 cm squared gives us 39.29 centimeters squared. So the area of our figure is 39.29 centimeters squared. We look at how to find area of plane shape using trigonometry. Remember, in our last class we talked about sines and cosines of an acute angle where we dealt with our SOHCAHTOA principle. SOHCAHTOA. Now, we have a triangle on the board, and I gave us the formula for calculating the area of the triangle to be half times base times height. Half times our base times our height. Now, in some cases, we also use another formula for calculating the area of a triangle. Half times A times C times sin B, and so on and so forth. Now look at what we have on the board. The capital letters A, B, C represent the angle. Capital letter A represents angle A, angle B, and angle C. And I remember telling us that the side opposite angle A is side A. So we have angle A, the side opposite is side A. We have angle A and side A, angle B and side B, angle C and side C. For us to apply our area of triangle, which is half base times height, we have half, our base here is side A times height. Half times A, which is our base, times height. Now, using our SOHCAHTOA, sin B, sin theta is opposite over hypotenuse. Sin of angle is opposite over hypotenuse. Sin B now, sin B is opposite, our opposite becomes our H. H over hypotenuse is C. Sin of angle is opposite over hypotenuse, and our sin B is opposite because the side opposite our theta, which is B now, is H. So we have opposite, which is H over hypotenuse, which is C. So we have H over C. If we cross multiply, H will give us C sin B. H will give us C sin B. So we put this, we make substitution. Now we put in place of H, we put C sin B for our formula. So we now have half times A times, instead of H, we now write C sin B. That's how we got the formula, half times A times C sin B. We got the formula from our trigonometry where we say sin B is opposite, which is our H over hypotenuse, which is C. Opposite over hypotenuse. At this point, we cross multiply. Our H gives us C sin B. C times sin B. Now from our formula, half base times height, we make substitution. In place of H, we put C sin B. So we have half times A times our H, which is now C sin B. Half times A times C sin B. This was our formula on the board. So now, in cases where we are not giving our height, we can apply this formula. In cases where we are not giving our height, we can apply the formula where we have our sin B to be our angle theta here. So it's not enough cases that we use half base times height. In case where we are not giving one of these, we use either this, half AC sin B, or half AB sin C, or half BC sin E. So we solve the problem. the formula as area is equal to base times height, as you can see on the board. In the case where the height is not given, we use our area to be AB sin theta. AB sin theta, because if we make substitution, our H will give us our H will give us A sin theta. So we either use base times height or we use AB sin theta for calculating the area of a parallelogram. Now let us apply our formula in solving this, calculating the area of this triangle. We have a triangle on the board with a base and no height. Since there is no height, we cannot apply our area of half base times height. This formula cannot be applied here because our height is not given. So we use our SOHCAHTOA to find our height, and our sine of angle gives us opposite over hypotenuse. Opposite over hypotenuse. So sine 68 gives us H over 6 cm. H over 6 cm. So we cross multiply, we have H equal to 6 times sine 68. H is 6 cm times sine 68 degrees. Using our 4-figure table, sine 68 degrees will give us 0.9272. So we have 6 cm times 0.9272, and that gives us 5.56 centimeters. So our height is 5.56 centimeters. Having gotten our height, we now use our formula half base times height for area of a triangle. So we say half times our base of 9 cm times our height of 5.56 cm. If we solve through, if we multiply, we get 25.02 cm squared as the area of this triangle. Let me run through it again. We have a triangle with no height given. So since there is no height given, we don't apply the formula directly, half base times height. We first find our H using our SOHCAHTOA. Sine 68 gives us opposite over hypotenuse, which is H over 6. H over 6. From here we cross multiply. H will now give us 6 times sine 68. That is 6 times our 0.9272, which is sine 68. We multiply this, we get 5.56 cm, which is now our height. We now use our formula half times base times height, because our height is we've now found our height. So we use half times base times height. Half times base of 9 cm times our height of 5.56 cm. And that gives us 25.02 cm as our area of the triangle. For the first one, we use our formula, which is half times base times height, to solve this. We can also apply trigonometry directly, where I give all this formula, half AC sine B. Half AC sine B. Now, from our triangle, we have our A, which is 9, and our C, which is 6. We have angle A, the side opposite is 9, and angle C, we have opposite, which is 6. So our half AC sine B, we have half times 9 cm times 6 cm times sine B. We have our B here in the triangle. We have our B and we have angle 68. So our B now becomes sine B, which is sine 68 degrees. So that gives us half times 9 times 6 gives us 54 times our sine 68, which is 0.9272. 0.9272. So 2 here is 1, 2 here is 27. We have 27 times 0.9272. That gives us our answer, 25.03 centimeters squared. You can see that our answer is very close to what we got here, 25.02 centimeters squared. The reason is because we started with the trigonometry. From there, we got our H first, before applying it to get our area from half base times height. But in this case, we apply our trigonometry directly, half AC sine B, where we have our A and C to be 9 cm and 6 cm respectively. And we solve all this to get 25.03 centimeters squared as our area of a triangle. With this, we have come to the end of the class. I'll give you an assignment when I'm done with this topic. So I want to urge you to study all what we have done today for better understanding. See you next week. Bye.